Hey guys, today we're going to work on solving systems of equation using substitution. There are many different ways to solve systems of equations, well, three that I know of, and today we're just focusing on substitution. It's a great introduction to the basic solving of systems. So before we get started, we need to know what a system of equations is. A system of equations are two or more equations that are grouped together and compared. So you're looking for a solution to the system that is an ordered pair. So if you think of graphing, so if you look up the top here, I have a graph, and where the two lines intersect is called a solution to the system. So whatever ordered pair that you put in would make it true. So this looks like it's the ordered pair 2, 1. So if I put the ordered pair 2 in for x, what's 2? 1 in for y, plus 1 equals 3. It makes it true. This ordered pair would also make this equation true because it's a point of intersection. If I put a 2 in for x, I get 2. A 1 in for y, I get minus 2, and that is equal to 0. So this point is a solution to both equations, calling it a solution to the system of these two equations. Now the system can be 2 equations, 3, 4, what have you. So today we're going to learn about substitution. So I want your eyes to come over here. If you have y equals 4, you can substitute that into the other equation for y. So you replace this y with a 4 and solve for x. Your final answer is going to be written as an ordered pair. Remember, x comes before y, and that is called the solution to your system. This picture down here is a set of parallel lines. So there are times when your lines are parallel, they'll never touch, so there's no solution to that system. There's also a method called the elimination method. We're not going to learn about that today, but that is a possibility. There's also the graphing method right here. So graphing, substitution, and elimination. Today we're just focusing on substitution. So substitution is when you replace one value for another equivalent value. So if y was 4, and if the equation said 3y plus 2, you just replace the y with a 4 because it's equal to each other. So today we're just looking on substitution, and you guys have been doing this. You just plug in for a variable to solve for another variable. So we're going to practice doing this. You need paper, pencil, and possibly a calculator. Make sure you pause until you're ready and go ahead and go. So this is our first class practice. Now usually you also see brackets on the side of systems just to show you that it's grouped together. So if you see something that looks like this, looks kind of like a face, that means it's called a system because they're grouped together. So in this one you have y equals 2x minus 4, and you also have y equals x minus 1. Well, let's stop and think about this for a minute. What do you notice that's the same in both? Did you see the y? Y is equal to this. Well, if y is equal to 2x minus 4, how can y be equal to x minus 1? Do you agree that y is the same as y? Well, yeah, y is y. So let's set these two equations equal to each other. Since y is equal to y, we can say that 2x minus 4, which is y, is equal to x minus 1. Because this is y right here, and this is y, and y does equal y. So let's set that up so that we can solve for x. So this we've been doing in our multi-step squiggle problem, stupid line, what have you. You want to put a coefficient in right here, you can. We're going to start by getting all my variables on one side and all my numbers on the other. So I'm going to move this 1x by subtracting 1x from both sides, making sure you line up your like terms. I'm going to add 4 to get rid of this here on both sides. So when you're done, your math is going to look like this. I have 2x minus 1x, which is just x, and negative 1 plus 4. Negative 1 plus 4, they're different signs, so you're going to subtract, and you're going to keep the sign of the bigger one. So x is equal to 3. If x is equal to 3, you can then substitute it into either equation. So you could put it in here for the x value, or you could put it in here for the x value and solve for y. I think it's easier to use the bottom equation, so I'm going to write that bottom equation again. And again, you can pick either equation, and I'm going to substitute a 3 in for x. And when I do that, I just plug that in for x. My y is equal to 2. So when I'm done, I'm going to write my solution to the system as an ordered pair. And ordered pairs are always x then y. So my x value is 3, my y value is 2. So this is called your solution to the system. So if you were to graph this, these two lines would intersect at 3, 2. All right, lovelies. This is the next example here. If this is a system and we wanted to solve it, Notice that y is the same as y. So if you have y equal to each other, you can then set what they're equal to each other. So I'm going to start by writing down 3x plus 1 is equal to 2x minus 1. My whole goal is to get eventually an ordered pair for x and y, which is called my solution to the system. So if you want to write that down, you can. That is my end goal. I have to get x, but then I'm not done. I have to plug it back into one of my equations to solve for y as well. So you want to start by getting all your variables on one side. Again, it doesn't matter which variable you start with, as long as that when you're working, you get all your variables on one side and all your numbers on the other. So doing this, you could divide by 1, or you could just realize that x is the same as negative 2. So now that I have my negative 2 for x, I can put that in to my solution. But now I need to get my y value. So you could choose either the first equation or the second equation. I usually choose which one looks easier to me. Would you rather take negative 2 times 2 or negative 2 times 3? You could look here too. Would you rather add or subtract? I'm going to pick the top one. So I'm going to write my equation y equals 3x plus 1, and then I'm going to substitute this x value in for x. So y is the same as 3 times negative 2 plus 1. Order of operations, PEMDAS, multiplication first. I get negative 6 plus 1. Different sign, so I need to subtract, and I keep the sign of the bigger one so I can be exact. Negative 5 is my y value. So my solution to this system is the ordered pair negative 2, negative 5. So if I were to graph these two on a coordinate grid, my solution, or where they were intersect, would be at negative 2, negative 5. That would be the point where my two lines intersect. Let's go on to our next example. Why don't you try writing a bracket? You start, it kind of looks like a face. Start at the top, go down, do a nose and a chin. And that is a bracket and tells you that it's grouped together. Again, systems can have 2 equations or 3 or 4. Usually you don't see it much more than that, but you can. It just means that they all intersect at the same point. So I'm going to set them equal to each other. And now I'm going to solve for my variable. I'm going to subtract an x. If you'd like to put a coefficient here to help you, you can. I'm going to add 3 to both sides. And I get my x is equal to 1. Pause the video and see if you can determine what my y value is. I just wanted to prove to you that first equation, if you plug in your x in the first equation, you'll get y equals negative 1. If you choose the second equation, you plug in a 1 for x and you'll still get y equals negative 1. Your final answer needs to be written as an ordered pair, and ordered pairs are always the x value first, followed by the y value. They are hugged by parentheses and separated with a comma. So your x value is 1 and your y value is negative 1. So that means if you were to graph these two equations with the slope being 2 and the y-intercept negative 3, and graph this equation with the slope 1 and the y-intercept negative 2, where they would intersect would be at 1 and negative 1, and it's called a solution to the system. Okay, one more. Let's see if you can get this one on your own. Pause the video, and then I'll work it out with you. So I set them equal to each other because y is the same as y, and you're not always going to see that. You might get something like y equals 2 in the second one, and then you just plug in a 2 for y. But this is what we have to work with, so I'm going to get all my variables on one side and all my constants on the other. It doesn't matter which variable you start with. And I'm going to cross these out because I get 0. I get 5x here. I want to move this number to the other side, so I'm going to subtract 3. And when I subtract 3, I get 0. To isolate my variable, I divide by 5. And any number under O divided by n, 0 divided by any number, it's going to be equal to 0. You could also use your calculator. 0 divided by 5 is 0. If x is 0, you can plug in this 0 into either the first or the second equation at the top to solve for your y. I'm going to pick the second, just because it doesn't have a negative. 3x plus 3. So y is equal to 3 times 0 plus 3. Well, 3 times 0 gets us 0, and 0 plus 3 is 3. So my final answer needs to be a solution to the system. I need to have a ordered pair with my x value first, followed by my y. My solution to my system is 0, 3. So if you graph these two equations, this one had a slope of negative 2, and it would go down, starting at 0, 3. And this one would start at 0, 3 as well, but it would go up. So the point of intersection is also the y-intercept. It is at 0, 3. All right, example 5. Pause it and see if you can set it up on your own. From here, I'm going to add a coefficient of 1. I'm going to subtract 1x from both sides to get rid of my variable term on this side. I'm going to move my constants to the other side to get rid of my constants on the right. And now my math is just here. I have -1 plus 7. They're different signs, so I'm going to subtract. And 7 minus 1 gets us 6. On this side, I also have different signs of a positive and negative, so I subtract. I get 2x. To isolate my variable, I divide both sides by 2, and I get an answer of 3 is equal to x. Now from here, I can substitute either the first equation or the second equation to solve for y. The first equation looks a little bit easier, so I'm going to go up top here and substitute in a 3 for my x and get my y value to be 2. From there, I'm going to write my answer as a solution to my system. That means the point where they intersect. My x value comes first, followed by my y value. And this is called the solution to my system. Nice job, guys. Elfine. Thanks for being you. Rock on, keep on keeping on. Let me know if you have any questions as you practice your formative assessment. Thank you. Love hugs. Bye.